From the previous video, we very quickly went over some two examples about the confidence interval. So let's review that again. But before that, let's see the demo first. So in that example, actually we talk about using the confidence interval for the newborn baby weight example we had before. So that's using this one to calculate the confidence interval. So if you remember, we have this birth information from the previous couple lecture. Okay, so then here, let's remind you a little bit. So that show the birth table. So if you remember, here is our newborn baby weight. We have about 1200 data. Okay, so from this one actually is sample data already. Okay, so we're using the confidence interval for unknown population mean, right? Okay, but our San Francisco city worker example earlier, that we have the population data. So then we just using the bootstrap method to show you how our result is what we expected. So we compare to the real population data. But now the confidence interval actually we use for the unknown population. So that we want to find the parameter from the population. Okay, so what we have is only the sample data. Okay, so that's why here our newborn baby table, this one actually is a sample data. Because there's so many newborn baby and so many mom. But here we only get about 1200 data here. So that's the sample data. So from this sample data, if we want to estimate the population mean, for example, we want to know the average age for the mom. Okay, so for the maternal age. So then here we can see, we can draw the histogram. Okay, so that's, you see the distribution for this sample data. They have the age from 15 to 45. Okay, so then of course from here we can calculate the sample mean. So that's, we got our sample mean here. So for this sample mean, that's 27.23. But we don't want to just use this data to say our population mean is 27.23, right? So instead, we want to use this one. That's our sample data. Okay, so then we apply the bootstrap method. Okay, so then we can have our confidence interval. So then from that range, we have pretty confidence, like 95% confidence to say the mean will be in that interval, about 95%. Okay, so that's why here is the question. So what is the average age for the mom in the population? So that's why we can use this sample data, we do the bootstrap. Okay, so in order to get one bootstrap resample, so you just do the resample, call the birth sample again. So remember, we're using the same sample size. We do with replacement. So that's why you can get one average from your resample. But this one just one, right? We define the function. So of course we want to run many times. So this one we just say we will run 3,000 times the bootstrap samples. So that's why we repeat 3,000 times. So each time we call the bootstrap mean function. Okay, so then we just, each time we append our average into our array. Okay, so that's, we will have an array size, or the bootstrap means will be 3,000 average in there in that array. Okay, so from here, then we can draw our histogram. We can draw our empirical data. Then that gets the 25% confidence. So that's why from our bootstrap, that's 3,000 data. The percentile method for the confidence interval that choose the confidence interval is 95%. So then we call that's a 95% confidence interval for the mean age in the population. Okay, so then of course we need to find our left and the right. So the left side, the lower bound will be the 2.5 percentile. So then the higher bound will be the 97.5 percentile. So then we get that. Okay, so that's why here you get your range. So remember, each time they run will be different. Just be in this time we run our 3000 bootstrap sample. So we get the average, the mom's average age from the population. Our confidence interval is between 26.88 to 27.55. Yeah, of course, to make that histogram to see the distribution will be always better. So that's our visualization. Okay, so this one is our empirical distribution. Okay, from our 3000 bootstrap resample. So that's why here, like earlier we said, right, we kind of see, right, this distribution is kind of the bell curve. So that's why we think the bootstrap is a good technique applied from this example. So then earlier, according to our left and right boundary, so then we put in here. So that's why we will have 95% confidence think our population parameter, the average of the mom, will fall into this range. Also, this range is about 26.88 and 27.55. Okay, so remember again, our confidence interval we calculate from here is just, we can say, from 95% confidence interval, we have the 95% confidence the population average will fall into this range. So our range is 26.88 to 27.55. So now we back to our question from the previous video. So that's the example we showed you earlier, right? So we say about 95% confidence interval for the average age of the mom in the population is this one. So that's why you can see that's our confidence interval. Interpret what we have. And here the number may not exactly as earlier we run. Because like we say, each time you run your bootstrap resample, so that's according to that we have an interval. Okay, so the same thing. From here, our demo, that's our interval. Okay, but this example here, the number is different. But it doesn't matter. Either way, we have the 95% confidence level. The average age of the mom will fall into in this range. So that's why if they try to interpret like this, so we see here that's true or false. There is a 0.95 probability that the average age of the mom in the population is in the range of this range. So we need to be very careful. We just say we have 95% confidence the average will fall into this interval. It's just the parameter, the average is fixed. The interval is fixed according to each run. So this 3000 run, that's the interval they get. And your file, you run 3000 times. Your result interval may not exactly as this. But doesn't matter. That's each time you run, the interval is fixed. We only say the average for the population of the mom's age we have 95% confidence they will be in this interval. It's nothing related to the probability. Okay, probability is just a random sample. Okay, so here we have our result. We just told you the confidence. So it's nothing related to the probability. Okay, so that's why the parameter is either in the interval or not. Just we told you we have 95% confidence. So you pick an interval, there's no probability involved. So that's the second discussion question we covered from previous video. So after we demo to show you the example. So here we just go back to see the same thing like this question, in case you are not quite sure and understand, because we went very fast from the previous video. So the same thing from our demonstration. We just told you we got to approximate 95% confidence interval for the population, for the mom's age, average age from the population is in this interval, in this range. Okay, so we have 95% confidence the population average will fall into here. So then if they try to interpret like this, true or false, about 95% of the mom in the population were between this range. So again, the same thing, this one is false. We only told you the average will have 95% confidence will fall in this interval. But how the real population distribution look like, we have no idea about that. So that's why we have totally no idea that will have 95% of the mom in the population, the age is in between this interval. Okay, so we are estimate the population average. We are not estimate to know how each sample how each individual in the population will look like. Okay, so that's our confidence interval. I hope that help you understand better. So you can went through this slide again, think about that. Okay, so the 95% confidence, that's the confidence level. This confidence level will give us the interval of the estimate of the parameter based on the random sample. Okay, so the process, we will give an interval for that. So a good interval, of course, that will contain the parameter. The confidence is in the process that create the interval. Okay, so it generates a good interval with chance 95%, with the 95% confidence. So the confidence interval also we can use for the testing. Okay, so this testing we will see here, that can be used for our hypothesis testing as well. But this hypothesis will be a little different. Okay, so usually we use the confidence interval for this kind of hypothesis. Your null hypothesis usually is talk about the population average or population median. Remember, usually we can use for that. They have the population average exactly equal to one value. So that's our null hypothesis. So of course, you know the alternative hypothesis will be not, right? Okay, so that's our hypothesis. So our confidence interval, usually we can use for this hypothesis testing. So how we know they are not equal to? Yeah, we cannot exactly to say they are not equal to. So one thing is we will tell you under certain confidence level, we can prove, we can show you, should we reject the null hypothesis or do not reject. So that's why you have a p-value. So this p-value is, like we say, actually is outside the confidence level. So that's why you will construct a 100 minus p% confidence interval. So for example, earlier we like to say 95% confidence, right? So that means our p-value is 5. Okay, so then you have that confidence interval. So we can try to figure out what range for that interval. So of course, if x is in the interval, okay, so then we do not reject the null. But if the x is not in the confidence interval, so of course we reject the null. So that's usually the confidence interval we use for our testing. So to be more specific, we can use our the birth example. So using the confidence interval for the testing hypothesis, so we can say the null hypothesis is the average age of the mom in the population is 25. Okay, so then the alternative will be the average age of the mom in the population is not 25. Okay, so then we can using our 5% cut off for the p-value. So that's why we can see in that 95% confidence level, this 25 fall into there or not. Also, we just using earlier our example. Yeah, since we have that 95% range is here. Okay, and then you will see the whole distribution is like this. Also, you can see 25 actually is not in this range. Also, then we will reject this null hypothesis. So that's our lecture 24.